Hi, welcome back to another video of making a programming language with JavaScript. In this video, we're going to be looking at how does a parser work. And if you're following along with Bob Nystrom's book Crafting Interpreters, this is chapter 6 of his book. In the last video, we looked at how to code up a grammar for our syntax tree. So now that we have a way of printing out our syntax tree and a grammar for it, we're going to be looking at parsing. So what is parsing? Parsing is not regular expressions or using any regular expressions to make sense of our language. We're not doing any of this. And I like Robert Nystrom's quote about parsing. So he says, writing a real parser, one with decent error handling, a coherent internal structure, an ability to chew through a sophisticated syntax is considered a rare impressive skill. And in this video, you'll be learning how that works. So this is the grammar for our new programming language. We have these 4 different types of expressions. But, and there's a but. It's a bit ambiguous. So let's say we have this simple expression, 6 divided by 3 minus 1. Now, what do we do first? Do we do 6 divided by 3 first and then minus 1? Or do we do 6 divided by whatever is in here, 3 minus 1? So right now, with what we have, we aren't able to parse this properly according to what we know it should be parsed as. In order to remove ambiguity, we need 2 things. One, precedence. Precedence is basically which operator is evaluated first. In the previous example, we know that in our rules of math, we do division first, and then we do subtraction. And then associativity. This means which operator is evaluated first in a series of the same operator. Is it left associative or is it right associative? So if we have, say, 5 minus 3 minus 1, left associative means that we do 5 minus 3 first, and then the result of that minus 1. So this summarizes the rules that we'll be looking at. All right, so equality are these 2 operators, and it's left associative, same for comparison. Term, which is minus and addition. Factor, divide and multiply. So all these 4 are left associative, meaning that, let's say we have 5 divided by 3 times 2. We're going to start from the left side and then keep on going to the right. But, and there's a but, unary is right associative just because of how this operator works. If you have bang, you want to associate that with the next literal, whatever it is. It can be bang, true, and then that whole thing is a unary unit. Or you have this minus sign and 5, so it's a negative 5. It's not right associative. So it's not left associative. Unary is right associative. And then this is how our associativity and precedence rules look like in the code format. So at top level, we have whatever expression we pass at, we're going to pass it first to the equality rule here. And that means that basically everything at the top is a low precedence and everything at the bottom is high precedence. So that means we check for everything at the top first and we keep going down, keep going down, keep going down until we hit something that matches our rule. So we're going to go from expression, pass it to equality, and then check if it's a comparison, pass it to term, check if it's a factor, check if it's a unary, and then we check if it's a primary, and then primary is our base level here. And I'll have an example later on to show what this exactly means. And in order to do that in our code, which we'll be looking at the next video, but in this video, we're going to look at an example of how this works. We're using an algorithm called recursive descent parsing. It basically, when you're writing a parser, there's different ways of parsing. This is one of the simpler algorithms, but it's used in many important programming languages, so it does work really well. Now we're doing top-down parsing. It's the simplest way, and we don't need any complex tools, so we can code this all on our own. With recursive descent parsing, this top-down parsing, we're starting from the top, which is the outermost grammar rule, and we're working our way down. So we're going top to bottom, and this means we're going from a low precedence to a higher precedence. And now let's look at an example to make this make sense. Now we're going to look at 6 divided by 3 minus 1. First off, we're going to go look at 6. This is a literal, which is just a number. And how do we hit this? So we basically went down our whole list of our rules here. Expression to equality, equality to comparison, term, factor, unary. It's none of this. It's a primary. It's a number. And a number falls under a literal. So that's why we have a number here. Next up, we have this division sign. So division falls under factor here. Division factor. And we know that this type of operator here, this is a binary type because we have expression, an operator with another expression. So what this means is that binary has 3 different types of things we pass into it: a left expression, operator, and a right expression. So in this case, what's left of it is the number 6. An operator is this division token. And then what's right of it is it the number 3? Yes, it is. And that's how we get the binary grouping for this. Next up, what we have is the number 3. This is a literal number, and again, it's because if you go down this list, you see that, okay, it's a number, it falls under primary, and primary is just a literal. Next up, we have this minus sign here. And minus falls under term because there's a minus sign here. And we know that this operator is a binary because it has an operator here followed by expression on the left and the right. So how do we make this binary object? Well, we know that what's on the left. So the interesting thing here is that what's on the left is not the number 3. It's actually this whole binary expression that we just parsed here. So let's make this arrow here. What's on the left is this whole binary expression. The token is this minus sign. And then what's on the right is the number 1. And yep. And again, this is because the 1 is falls under the primary rule here, precedence here, and it's a number, so it's a literal here. And that's our example. And one more thing we'll have to do in our parser is to make sure that we handle errors very well. There's 2 things we want our error handling to do. We want it to detect and report errors, and we also want to avoid crashing or hanging. So how do we do that? Well, we very simply, whenever we're parsing a line and we see something that that doesn't make sense, something that doesn't follow any of our rules, we're going to discard that. So in this line here, so actually we're doing that because we want to avoid crashing or hanging. We don't want to be in an infinite loop state. So in this example here, so this plus and then this divide and 1, everything here doesn't make sense after the var. So we're actually just going to discard this line here. Don't want that, and don't want that. And what we're going to do is start parsing again from the next line. And then see if the next line makes sense. If it does, we're going to parse it. And in this case, our next line does make sense, and we're going to continue parsing. And this is how basic error handling will work for our language. In the next video, 3b, we're going to code up an actual parser using everything that we learned in this video, all the concepts that we learned. If you like this, please hit the like button and subscribe to get notified of the next video. Thank you for watching.